Okay, now here's another type of problem. And what we're looking at here involves using some math for the farmer who is going to fence in his property with a river as one of the boundaries. And so there's a restriction, and that is there's only 5,000 yards of fence. So given that restriction, and given how we're going to set up the problem with the river as a fourth side, what would be the maximum area? How could we rearrange the dimensions to get the maximum area? Because the farmer wants to enclose as most of the land as possible. That would be something the farmer would want to do. Okay, so first to model the problem, we got our river. Okay, and so now we got to have defined variables. All right, so since this is going up and down on my model, I'm going to call this y, and I'll call this x, and then this is also y, because we're going to assume this is a rectangle. There are more advanced problems where we don't assume anything about the shape. And that would be, what would the shape be that enclosed the maximum area? That's kind of more, again, you got to use calculus for that. So we're assuming it's a rectangle. All right, and so now we get the perimeter, which would be adding these three sides. And we already know what that is, that's 5,000. So we have our perimeter equation. Now, what do we want to maximize? The area. How do you get the area of a rectangle? X times y. So we have two equations, which means we're going to have a system of equations. What we have to do first is construct a model of the problem. Then we got to decide the variables. What are we looking for? The dimensions. So x by y would be the dimensions. We set up a perimeter equation, which would be adding the three sides. We know what the perimeter is because that's the amount of fence, so 5,000. I'm just ignoring the units. Okay, and then what we want to maximize is the area. So we have the area function, which would be x times y. Now we need to create a quadratic with the area function. And so notice what we can do. We can go up here and solve for x by subtracting 2y. Now we can substitute that into the area equation, and we'll get a one variable equation with y, and it'll wind up being open down parabola. All right, so now when we multiply out, we're going to get negative 2y squared, and then we're going to get 5,000 y. Okay, and this is the equation we're going to use. We have one variable. It's a quadratic. What would be the maximum area? So basically, just like the warm-up, which is kind of why I did that, this would be the point where the maximum area occurs. And since we have the y there, we're going to get the y first. So we're going to get the y first because that's what's happening in our equation. Then we'll use the y to get the x. So we're finding the vertex. Maybe you want to be negative b over 2a. Okay, you could do that. We could also do the same thing. Get the x-intercepts and pick the midpoint. That might be easier. That's what I would do. But again, if you like negative b over 2a, that's definitely an option. All right, so I'm going to go ahead. I'm going to factor out. I'm going to factor out a negative 2y. And then this is going to become 2,500 minus y. Okay, so now look, you can even see what it is. Okay, and I realized I switched the variables, so this actually should be y, not x. Since the input variable is y. I know that's a little confusing perhaps, but it's because of what happened here. So this is actually based upon a y. Okay, so then now what we got is 0 and 2500. Okay, so then in between that, so if you got your negative b over 2a, you would get this. All right, notice the negative 5,000 over 2 times negative 2. So if you did that, this is what you should get. So if you did your negative b over 2a, you should get that. So you get the same thing. All right, well, now we know y. We can put it right back here to get the x. Now we just plug that in right here. And so you get 5,000 minus 2 times that, which is 2,500. Okay, so this would be 2,500. And this would be 1,250. So that's the dimensions that would maximize the area.